It's recording. All right, today's exercise, we're going to work on 3C. Now, before we start 3C, let's do a bit of a recap. What did we do in exercise 3A? Can I please have Yi Chen? What was 3A about? Well, that is not 3A, but that is 3B. Add and subtract is part of 3B. What was 3A? Before you can add and subtract, you have to learn something about fractions. Ignore. Equivalent fractions. You needed to understand why is it that whatever you do to the bottom, you do to the top, but it only works for multiplication. So an example is 2 over 4. If I change it to something with 8, then whatever I do to the bottom times 2, I must times the top by 2. So 4/8 is equivalent to 2 over 4. First skill is to learn to simplify fractions. Okay, so that's 3A. Then 3B, yes, we had add and subtract. Before you can add and subtract fractions, what do you have to check for? Can I please have Attila? Before you can add and subtract a fraction, for example,
make sure that the denominators are the same.
Beautiful. The denominators need to be the same for you to add. Someone explain to me why. So what was I explaining? Why do the denominators have to be the same in order for you to add? What are the reasons I've been trying to hound down on you or tell you many times? What's the reasoning? Yes, Sarah? Yeah. Yes. Let's elaborate a bit on that. So Zara is saying 1 whole, which is that number 1 represents a numerator. But when you put a denominator value, Fitzroy, the denominator value actually tells you how many pieces of 1 whole do you cut it into. So this is saying if you had 1 piece of a pizza, you're cutting into 3s. Whereas this one, if you had 1 piece of a pizza, you're cutting into 5s. 5 slices is much smaller than 3 slices. That's why each denominator, if you count them, they're very different sizes. Just like your chairs, there are some green chairs, there are some gray chairs. You don't count all of them as green chairs, and neither do you count them all as gray chairs. They all have to be the same color. Same thing with this one. Fractions, you can't add or count them unless they are the same size. That's the reason why you have to change the denominators. Okay? So don't speak while I'm speaking. I find it highly disrespectful. So 1/3 plus 1/5. The problem is that fraction there, they are not the same types. That's why you can't add them. But that's why you use exercise 3A. We can then rewrite each fraction that have the same denominator. But to have the same denominator, you got to find the lowest common multiple. What's the lowest common multiple? 3 and 5. Can I please have Jacob? 15. So we know that they will be the same size because they can all be rewritten as 15. So meaning 1 whole pizza, if you cut them into 15 slices, you can actually rewrite 1/3 as something out of 15 slices. So how do we figure it out? Equivalent fractions times the denominator by 5. 3 times 5 will give you the 15, but what do you do to the bottom? You do to the top. So that's why this is 5 out of 15 is the same thing as 1/3. Whereas 1/5 times 3, 5 times 3 will give you the 15. What do you do to the bottom? You must do to the top. And that is why, now these are the same slices. You got 5 of these 15 pieces, and you're adding on an extra 3 of them. That's when you can add them and count them. And you can say, well, in total, I have 8. Boys, don't speak while I'm speaking. I find that how disrespectful. If you can't sit there quietly and listen and contribute, then move. There's plenty of seats over here. Do you understand, Mateo? That's the second time I'm going to say, if you're going to go down again, I'm going to move you over here. Does that make sense? Thank you. All right, so that was add and subtract. But then in exercise 3B, there was also another skill that I split it up into 2 sessions. So last week you had 2 sessions to work on 3B. What was the second skill that you had to learn? Let's go with Ryan. What did we do in the second part of 3B? First part was add, subtract, and the second part must be? Very good. Multiply and divide. Now, when you're multiplying, the skill I taught you to multiply fractions. So, for example, 2 over 5 times 1 over 7. When we're multiplying fractions, it's not as difficult as add, subtract. And I showed you why that was the case as well. But how do you multiply fractions again? What do you do? Can I please have, let's go with Josh. How do I multiply fractions? What do I do? That is for equivalent fractions. But I'm not sure we're understanding the same thing. I'm going to pick someone else just to re-elaborate that. You do something on the bottom. You do something on the top. What was it again? Let's go Willow. How do I multiply? Beautiful. So, I'm not sure if that's what you meant, but it's top with top, bottom with bottom. So in primary school, this is how the teachers would taught you. For multiplication, you don't need the denominators to be the same. You just literally times top with top, bottom and bottom. Not so much whatever you do to the bottom, you do to the top. Because if I did 5 times 7 on the bottom, doesn't mean I times 7 on the top. On the top, I actually do 2 times 1. So 2 times 1 in the numerator, whereas the denominator is 5 times 7, and my answer is 2 on 35. This was multiplication. What about division? Division was one slight difference. So if I did 2/5 divided by 1/7, how do we divide fractions again? Yes, Carissa.
You have to flip the second fraction. Wait, was that thing? It was like KCF. Yeah,
That's right.
You
KFC.
keep the first fraction the same, and then you change the sign, and then you flip the fraction.
Very good. So you flip the 1/7. That now becomes 2/5 times. You change the sign, and it becomes 7 on 1. And we know how to multiply fractions. Top with top, bottom with bottom. 2 times 7, 5 times 1, and your answer is then 14 on 5. So that there, if I zoom out, these are the skills you have done. Right, move over here, please. These are the skills that you have done from last week. Doesn't mean that you've mastered. We've done a couple of quizzes, and I can tell some of you are still struggling with this bit. Okay, so adding, subtracting fractions of the same denominator. That is where... Matteo. Sorry, I said to move over there, meaning pack up your stuff and move over there. Thank you. So adding, subtracting different denominator is your second time this time to practice. Exercise 3C, we're going to be focusing on how to add, subtract, but with negative numbers now. So I'm going to repeat the same skill, but you're going to practice with this. Okay? Here we go. Let's do some examples. I've got 6 examples in total just to get you to get used to those skills up here. Those are the preliminary skills, meaning at chapter 3, what am I looking for? I do need to know that you can do what we call arithmetics of fractions. And that just means add, subtract, multiply, divide. Okay? Let's try this first example here before we fill it in. Remember chapter 1 integers, the negative in front of a number actually means, write this in, reverse or opposite direction. Now I gave you the number line to help you visualize when you do the opposite of the direction. Okay? So write in reverse. Let's do the first example. Example 1. We want to add these two fractions together. Now, before we can add, we have to check what again can I please have. Willem, what do we have to check? That's right. We're checking if they're the same type of fraction. Okay, is it the same size of a pizza? Yes, they are. This is a pizza, full pizza cut into 7 pieces. So I've got -6 of them. So notice that negative there. That's -6 of these pizzas. And you're adding on 2 of these pizzas. So how do you work it out? Well, how many 7s do I have? I have -6 of those pizzas plus 2 of those pieces together. Now, this is where you use your number line. What is, can I please have Hamza? What's -6 plus 2? Look at the number line, or you can tell me the answer. What's -6? And you're adding on 2. -4. Well done. So the answer, when you add them together, it should be -4 over 7. So if you think about the number line, let's draw the number line for those who aren't familiar. -6 started here. And you're adding So if you're adding, you're moving to the right. Moving to Mateo, I'm telling you, you're not going to focus, you're not going to write notes, you don't need to be here. You can go to middle school, okay? But if you're going to be in my class, I expect you to be listening, or actively taking notes. It's one of the two. But if you don't want to be here, don't be here. That's a choice you make. Does that make sense? I welcome you, but I don't welcome that behavior. It's disrespectful. What's your choice? You staying or you leaving? All right. Thank you. So, -6 is on the left-hand side. Add means you're going to the right. So I'm going to the right by 2, and we can see that the closer we get to 0, the smaller number, hence why it is -4. Okay, so that practices your chapter 1 again, so that you can practice on integers if you weren't perfect with that at that point. But your answer would be -4 on 7. Now, some students always wonder, does it always have to have the negative numerator? Doesn't. We normally write it like this. Negative on the outside and 4 sevenths. If you're wondering why, because negative of a number divided by a positive number, we know that the overall answer will be negative. That's why you don't have to keep it in the numerator or the denominator specifically. We normally keep the negative on the outside. Okay, if you had a negative on the top, negative on the bottom, then that would be a positive sign. Okay, so that's back to integers again. Let's do example 2. Example 2. Now we can see the denominators are different. 3 and 5. Lowest common multiple, 3 and 5. Let's go with Fitzroy. What's the lowest common multiple? 15. Very good. So we need to change the fractions so that they are 15ths. To change 3 to a 15, what do I multiply to 3? Can I please have Belinda? What do I multiply to the 3 to get a 15 in the denominator? 3 times 2 is 6. I'm asking that 3, we need to change it to a 15. Times it by 5. So we times the 5 on the bottom because we're changing by equivalent fractions. We're saying, well, 3 times 5 gives me 15. Whatever you do to the bottom, do to the top. Very good. So now you get -1 times 5 is -5. And on the other side, we have 5 times 3. Hamza, thank you. 5 times 3 is 15. Whatever you do to the bottom, you do to the top. 2 times 3 gives you 6. The only part that you're revising with integers is here. Thank you. Don't speak while I'm speaking. That negative in front, you've got to remember, that's like a -1. So when you say -1 times 5, you've got to go back to your notes. Positive, positive makes a positive. If the signs are the same, it's positive. If the signs are different, it becomes a negative. That's why I've got a -5 here. Okay, so -1 times 5 gives me -5 there. Now let's add and subtract. Next line, now that they are the same denominators, we're saying, how many 15ths do I have? I've got -5, and then I've subtracted another 6. Use a number line. Have a think. What's -5 minus 6? Let's go with Zara. -11. Very good. Again, -5 here. Minus means you go further left, and you go an extra 6, so hence it's -11. So you should have -11 in the numerator over 15, but like I said, you don't have to keep the negative in the numerator. We normally write the answer as -11 over 15. Mateo, it's the third time. It's actively listening or actively taking notes. Which one are you doing? Remember, you don't have to be here, Mateo. Yeah? You got to realize that if you don't want to be here, you don't have to be here. You make that choice. But don't be a clown for everyone else while I'm trying to teach. The same for you boys. He's only doing that if you guys are reacting. So whilst you're laughing at him, you're the ones who are causing it too. So you're being disrespectful to me as well. If you guys had already known this and you think I'm wasting my time, then I would have expected your quiz to be 100%, which wasn't the case. So whilst you're mucking around, you got to think about, was it maths that was hard or was it you? Is it your motivation, your hard work, your lack of hard work, or is it the subject? the more you blame, you got to remember it's about you. That's one of the things I hate most is that when students complain about maths, they're like, oh, it's too hard. Oh, I was never made for it. Then I'm like, well, did you try? Because if you didn't try, don't complain. You take it as it is and you be that. So you either listen or you take notes. If you don't want to be here, don't be here. Talk to your parents about it. Here we go. Next one. So you got negative 11 on 15. Let's go to example 3 now. Simplify. This one's just slightly different because I've got a mixed fraction in there. So with mixed fractions, one of the tips I told you from the last session is try to convert it first. Don't try to do the shortcut. Convert it first. So here, let's revise our conversion. How do I convert 1 1/5 again? Can I please have Adele? How do we convert a mixed fraction, 1 1/5, to a to improper fraction? Yeah. It's actually times. Times. So you times the denominator, so 5 times the 1, and then you add on to the top. So that's the shortcut method I showed you, but I also showed you the long way and where the actual thinking actually comes from. If you've forgotten it, make sure to practice the mixed fractions to convert so you get better at it. But let's convert that. 5 times the 1, don't worry about the negative because that's the number sign. 5 times the 1 is 5. 5 plus the 1 gives me 6. That's very good. So this is technically negative 6/5. Okay? Whilst this one is negative 8/3, subtract. That's my fraction there. So converting the mixed fraction makes your problem a bit easier. And now we've got to be careful. Now we ask ourselves, what am I doing here? I actually have denominator 3, denominator 5. They're not the same fraction, so you need to make sure they're the same fraction. Lowest common multiple, which we know 3 and 5, was 15. So same thing again, we need them to be 15, and this needs to be a 15. To get there, we already said before that we're timesing the bottom, times 3 by 5 to get 15, then you've got to times the top by 5. Negative 8 times 5 gives you negative 40. On the other side, 5 times a 3 will give me 15, but what do you do to the bottom? You do to the top. Times 3. Now you've got to be careful here. That negative is with the 6. That's a minus sign there. Negative 6 times 3. What's negative 6 times 3? Negative 18. Now the denominators are the same. Then we can count them. We can say, all right, how many 15s do I have? That's my 15 there. I've got negative of these 40s. So negative 40 minus negative 18. Now this is where you've got to work with chapter 1 stuff. So some of you from term 1 have mastered this. Some of you might have forgotten it. Some of you may need to practice it. But let's draw the number line to help you remember again.
32.
Not 32, but you're on the right direction. Think about it. Negative 40. Am I on the left or on the right? On the left. So negative 4. Let's say negative 40 is here. So I'm starting at this point. Now, when I subtract, which direction am I going? Left or right? I'm going left. But remember, the negative means reverse or opposite. So instead of going left, I'm meant to go
Right.
Go to the right. Very good. But if I'm going to the right, I'm going to the right by 18. Very good. But it's still, when you subtract 18, 40, take away 18, you're still on the negative side. So it's negative 22. Okay, very good. So rewrite that. So that now simplifies to negative 22 out of 15. So it's just working with that number line. So if you're unsure, draw a number line. Just make sure the numbers are correct or check with the calculator you've done it correctly. Okay? Next bits. Well, negative doesn't have to be in the numerator. You can actually write it as negative on the outside, 22 on 15. You can write that as a mixed fraction if you want as well. How many 15s in 22? We can say it fits in once. Remainder? 7 over 15. Okay, so it fits in one whole. Remainder 7 out of the 15. So you can write it as a mixed fraction or you can write it as an improper fraction. Okay? So if I zoom out, these are the skills that we're practicing. You have same denominator, different denominator, and then be careful with a mixed fraction in there. So there's a variety of skills there. So if I were to write a quiz, it'd be something like that. Starting off with same denominator, different denominator, and then a bit of a complexity here. That's add, subtract, so that helps you revise not only chapter 1, but it also revises what you learnt last week. Okay, so adding, subtracting, I'm going to do another quiz probably next week, and I want to see if you've improved on adding and subtracting, because you'll want to practice that skill to get better at the fractions component. Okay? All right, team. Flip over to the next page, thank you. All right. I'm going to do 3 examples, and then the rest of the session is your time to practice on 3C or 3B. You want to add, subtract, multiply, divide fractions. That's the goal. Okay? Here we go. Let's do the first example. All right, Josh. Let's ask again. When we're multiplying fractions, how do we do it again?
Top with top, bottom with bottom.
Beautiful. Top with top, bottom with bottom. So in this case here, we don't need to make denominators the same. You literally write down what you see. It's 3 times, that's a -1 on the top there, all over 5 times the 2. Let's work with our current numbers that we know. What's 3 times -1? Can I please have Xavier? What's 3 times -1? -3. Beautiful. So remember, when you're timesing, you're checking. Positive times a negative, positive, negative makes a negative. So if the signs are different, the answer is going to be a negative. Then you just do 3 times 1. So 3 times 1 is 3. 2 signs are different, so it's a -3. On the bottom is easy. Both numbers are positive, so 5 times 2 is 10. So your answer is -3 on 10. You can write the negative on the top, or you can write it as negative of 3 over 10. So negative on the outside. Same thing. So that's the scenario where there are no common factors, nothing that you can simplify. In the second example, though, yes, you can do top with top, bottom and bottom, but the problem is that numbers can get really large, and that means simplifying your fractions later is much harder. So I encourage you to find factors that you can simplify early. Now let's try this one. Instead of doing 5 times 18 and 9 times the 20 on the bottom, we're going to try to simplify it early. What 2 numbers that you can see have common factors already? Give me 2 numbers that you can see. Let's go with Belinda.
Oh my God.
All right, so we have 9. So pick a bottom number, pick a top number. 9 and 18. And 5 and 20. Now, you could have also done 18 and 20 as well. Doesn't matter. You can just keep reducing it. The point is to make it as small as possible. Okay? I would have done exactly what Belinda said, just because you're reducing it twice rather than reducing it once. Okay, so here, what number goes into 9 and 18? What's the common factor here? 9 and 18? 9. So you'd say, how many 9s fit in 9? How many 9s fit in 18? Let's rewrite the fraction again. How many 9s in 9? Can I please have, let's go with, who am I picked over there? Chen. How many 9s in 9? 1. 9 goes in 9 once. How many 9s fit in 18? Let's go with Mateo. How many 9s fit in 18? How many 9s fit in 18?
2.
Very good. So 9 goes in 18 twice. So this number is 2 over there. So the fraction is now reduced from 18 down to 2, 9 down to 1. But then you look at 5 and 20. What's the common factor of 5 and 20? Can I please have Charlotte? 5. So I can say 5 fits in 5 and 5 fits in 20. How many 5s fit into 5? Can I please have Attila?
1.
1. So that means this now becomes 1. And how many 5s fit into 20? Can I please have Jacob? 4. So this now becomes 4. So we've now reduced our fraction from 5 9s down to 1 over 1. But what are we missing? Don't forget. There's the negative there. Okay, so don't forget the negative. Keep the negative there. Same thing with this one. There's a negative there. Keep the negatives. All right. Before you multiply, I can still see another 2 factors, a top number and bottom number that has a common factor. Which 2 numbers can you see? Yes, Eknor. 2 and 4. And we can see the common factor is 2. So 2 fits in the 2 once. 2 fits in the 4 twice. So we can say this reduces down to 1 to 2. Now your new fraction is -1 on 1 times negative of 1 on 2. that is much easier to multiply now than your initial fraction. The initial fraction was much harder. Yeah, so from here, now we can do what Josh said. Top with top, bottom with bottom. So write it out. That would be -1 times -1 on the top. And on the bottom, you've got 1 times the 2. What's -1 times -1? Double negatives make? Plus. So it means it's +1. And then 1 times 2 on the bottom is 2. So your answer is a half. Okay? So just got to be careful with those signs. Do the signs later on. But that's an example of how you can reduce your fractions. Now that's multiplication. It's a bit harder. You've got to train your addition and subtraction first. Okay? All right, one last example, team. Eyes and ears towards the board. Last example, can you turn to example 7 on the bottom here just to practice? Division. Actually, we'll do 8 actually. 8 is a bit more tricky. Some students get this one wrong. So when you're dividing fractions, we know we have to do the KFC, keep the first, flip the second, and then change the sign, right? But notice the second, that's number 4. It's not a fraction. So what you should do when you see something like this, change the 4 to a fraction. Now what is 4 as a fraction? 4 over what? 1. Very good. Now when you're dividing fractions, we say keep the first one. So it's still -3 on 5. We flip the second fraction, which now becomes 1 on 4, and then we change the sign. So instead of division, it's times. Now you're back to what we're familiar with. Timesing is just top with top, bottom with bottom. So here we go. Top with top, bottom with bottom. Your answer should then be -3 times the 1 in the numerator. Denominator should be 5 times 4. So, my answer, -3 times 1. What's -3 times 1? Can I please have, let's go with Garissa. -3 is correct. So it's -3 because 1's a negative, 1's positive. Different signs makes a negative. And then 5 times 4 on the bottom gives me 20. And that's my final answer. Okay, so in exercise 3C, you're doing add, subtract, multiply, divide. But really, I think from the quiz, I think some of you can still work on your addition and subtraction. Your times and divide will get better if your addition and subtraction is better. Okay? But that's it for today. The others, I'll fill in the solution if you're interested in trying, especially these ones. They're just more of a thinking question. Is it positive or negative if I did -half to the power of 4 or negative of 1/3 to the power of 4? You've got to use BODMAS for that one. Okay? But that's your session now. So you currently have it's 2:30. You have, what's that, about 45 minutes to work on 3B or 3C, depending on where you're at. Thank you, team.